Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to talk about this common source amplifier with the PMOS as a load. These are the assumptions for this question, and we're going to look for the ratio of W over L for the M1 transistor. If we notice that the gain of we had to gain of -10 for this amplifier and the drain current of 0.5 milliamp. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button and also the notification bell, so whenever I upload a new video you'll be aware of it. Let's jump into it. This is the question from the Fundamental of Microelectronics book Razavi, chapter 7. This is the reference, and as it says, this common source stage provide a voltage gain of 10 and the bias current of 0.5 milliamp. Calculate the value of W over L. So how we can deal with this problem? First of all, I'm going to use a simple AC model to calculate the parametric voltage gain of this amplifier here. Okay, we have here V in as an input. This is M1 as the amplifier transistor, and M2 it works as a load. With VB as a bias, we can model this with the short circuit, because I'm going to use a small signal model, and VDD again is short circuit. So the gate and source, both of them are short circuit. So I can model this M2 with just one resistor, RO2, or R drain source 2 for M2. And this is ground and this is V out. And for M1, it is, you can simply, as my previous videos, you can see that for this common source amplifier we can use this formula for AV, V out divided by V in minus GM1 times R out. And what is the R out in this amplifier? R out minus GM1 times R out, this resistor RO2 paralleled with the resistance from here, the drain of M1 to the ground, which is RO1. Both of these resistors are parallel, because in one, this node is connected together, and this is ground and this is also a ground, so you can connect these two grounds together. Okay, so this is the formula for gain of this amplifier. Now I'm going to use these assumptions and use this formula to calculate GM1, and after that, because we're looking for W over L, we can calculate GM1 by having this mu on C oxide and also the drain current of this amplifier. Simple as that. So here we have AV of -10, which is equals to minus GM1 times RO1 parallel with RO2. Now, how we can calculate RO1 and RO2? RO1 for NMOS transistor, we have this 1 divided by lambda 1 I drain. So this is because of channel length modulation. Lambda 1 is 0.1 times 0.5 milliamp for the drain current, because this is in milliamp. RO1 calculated in kilo ohm. Okay, this is 0.05, and if I calculate it, you can get the result 20 kilo ohm. And how about RO2? RO2 for this PMOS transistor, 1 divided by lambda 2 times I drain, which is equals to 1 divided by 0.15 times IAD, which is 0.5 milliamp. If I using my calculator, I can get the result, which is 13.3 kilo ohm for RO2. So RO1 times RO2, parallel with RO2, this is the result. We can get 20 kilo ohm parallel with 13.3 kilo ohm, which is equals to approximately 7.98 kilo ohm. Now we can calculate GM1. For GM1 we have 10 equals to GM1 times, I just inject this to this formula, times this resistance, 7.98 kilo. So GM1 equals to, by using some simple mathematics, you can get the result 1.25 milliampere per volt. This is the unit for GM1. And now we can calculate W over L. So I'm using this formula. You should be aware of different formulas for GM1, and here, because we have mu NC oxide and GM and also I drain of this transistor, I'm using this formula for GM1. Okay, we have 3 different formulas for GM1. You have to be mastered in all of them. So the result for W over L1, by simply you can take the both sides and use the square root for the both sides. So W over L1 equals to GM1 to power of 2 divided by 2 mu NC oxide W over I drain. And the result is going to be, let me just simplify this, 125 milliamp per volt squared divided by 2 times, this is actually 0.2 milliampere per volt squared times 0.5 milliamp. You see, this milliampere squared by these 2 milliamps are cancelled out. 2 times 0.5 is equals to 1. So 1.25 squared divided by 0.2, which is approximately 7.8, the result for W over L ratio of this transistor. This is the final answer for this problem. I hope you like this video, and if that's the case, please give me a thumbs up and share this video with your friend. Thanks for watching.